guys, today we have zeros in the standard algorithm. Guys, we're on lesson 21, and there's 23 lessons in this unit. So we are getting close to the end. Today's learning target, let's subtract numbers with several zeros. So today's lesson is going to be a little bit harder than yesterday. For your warm-up, we are doing which one doesn't belong. In your books, it says A, B, C, D. And in my book, it's 1, 2, 3, 4. So start by looking at those numbers. Decide which one doesn't belong and be prepared to tell me why. Are you guys done already? Just put your hands down. We're giving everybody a chance. All right, which one doesn't belong? Okay, Vivian.
C, because there is a decimal point. There's no zero at the end of 2.
Okay, so maybe because we have a decimal, maybe C doesn't belong. Delaney, what do you think?
I think A because of A, B, and D. A, the ones place doesn't end with a 5.
Okay, so maybe it's A because it doesn't end with a 5. Okay, what else? Gage, what are you thinking?
D because it's only 1 in the 10,000.
Oh, because it goes all the way to the 10,000s, so maybe it's too big of a number. Okay, let's hear one more idea. Kaylin, what do you think?
The only one that ends in a 0, I think B because it's the only one with 2 5s in it. C because of the decimal point, and D because it's in the 10,000.
Okay, I think any of those answers would work. But let's think a little more deeply. What if we subtracted 44 from each of our whole numbers? So not looking at this decimal. What if we subtracted 44? What do you think? Brayden.
I think number 2 on yours would be the easiest to subtract because 55 minus 44, if you count by 11s, it would just be 11 because it's the same as
Yeah, those are math facts that we should know, right? So those are the kind of numbers that are easier to work with. How could we subtract 44 from the other whole numbers, like this number and this number? How could we do that, Michael?
for number 1, it will be easy because if you do 2050 minus 44, because there's only a 4 and then it's only 14 left. 2014.
Okay. What else? Cade, what do you think?
Well, I think you could just do it in your head because you know that 50 minus 44 equals 6, so it would be 2006.
So if you just know 50 minus 44 is 6, and if you think about it that way, it wouldn't be that hard, would it?
Yeah.
Okay, Brooks?
You could do the 40 minus the 50, and then you have 10, and 4 minus 10 is 6.
Very good. Okay, these are all very good methods. I love it. All right. We're going to look at activity 1. I think, is this what's in your book?
Yes.
Okay, perfect. So here are some numbers that you saw earlier. Each number has at least 1 0. From each number, 1,436 is being subtracted. For number 1, it says make sense of the problems and explain to a partner. Number 2 says use the approach in the first problem to find these two differences. And then, do we have a number 3? Number 3, find the value of each difference. Be prepared to explain your reasoning. If you get stuck, try subtracting using the expanded form. Okay, so it looks to me like today you're going to start by working with your math partner, and then I'm going to show you a method. Do you guys think you could do this?
Yeah.
Okay, Gage.
Would we do the whole page together?
You're going to do it with, 1, 2, and 3. Yeah, because number 1 says you've got to explain it to your partner, so I'm interested to hear your explanations. Okay. All right, you guys. So we are going to check A and B together. So I want you to make corrections if you need to. Make sure that it's correct. So for problem A, you're going to watch me first and check yours. So I always start with the ones column, right, guys? 5 minus 6 is 1.
No.
Oh, I was just checking to see who was paying attention. Okay. It's -1. You have to borrow, right?
Yes.
We have to decompose. I was seeing who was listening to me. All right. So I can't subtract, so I go to the next place. It's a 0. Can't borrow. I go to the next place.
Can't borrow.
Can't borrow. I have to come all the way over to the thousands. I'm going to decompose that 2. It becomes a 1, and I carry the 1. Guys, I have to borrow all the way over to the ones place. So I'm going to make that 10 a 9, carry the 1. Make that 10 a 9, carry the 1. Do you guys remember? And it becomes 15. Walking around, it seemed like at first we hit a wall, and then you guys kind of remembered how to do it, right?
Yeah.
So everybody, what is 15 minus 6?
9.
9. What is 9 minus 3?
6.
6. What is 9 minus 4?
5.
What is 1 minus 1?
0.
Okay, let me show you a common mistake. Sometimes kids put a 0 here and a comma. That's against the laws of math. You will go to math jail. And I can't afford to bail you out. So, just kidding. We never put a 0 comma at the beginning of a number. The answer is just simply 569. Okay? All right, let's look at B. 5 minus 6 is?
1.
Can't do it. Guys, we're not talking negatives, okay? Okay, I look to the next place. It's a 0. Can I borrow? No. Go to the next place. Can I borrow? Go to the next place. Can I borrow? All the way to the 10,000s. Guys, neatness counts. Okay? When you are borrowing for this many place values, ladies, when you are borrowing for this many place values, you have got to keep your numbers lined up. You don't want those ones to get tossed into the wrong spot. The 2 becomes a 1. I carry the 1. 10 becomes a 9. Carry the 1. 10 becomes a 9. Carry the 1. Okay. Once again, we have 15. Okay, what is 15 minus 6? Everybody? 9. What is 9 minus 3?
6.
9 minus 4?
5.
9 minus 1?
8.
1 minus nothing. 1, 2, 3, comma. 18,569. Okay. Guys, any questions about A, B, C, or D for number 3? Were there any you were stuck on?
Nope.
Okay. We're going to go on to activity 2. We just did that. All right, here is our launch. Write the year that you were born down and subtract that year from the current year. Gage, what year were you born?
What?
I didn't think you were listening to me. All right, Kara, what year were you born?
2013.
All right, raise your hand if you were born in 2013. Okay, the year it is right now is 2023, right? Kara over there was born in, 2013. Everybody, what's 3 minus 3?
0.
2 minus 1?
1.
0 minus 0?
0.
2 minus 2? Okay. 10 years. Are you 10 years old, Kara?
I'm
9. So you must have a birthday coming up.
This year, I'm going to be 10.
This year she'll be 10. Okay. Guys, this is a method that you can use to find the age of some of your relatives. Okay. Really quickly, did you guys all write down your year and subtract?
Yes.
Go ahead and do it if you haven't. Abriella.
So my grandma was making a chart of all our birthdays, and one time she wrote my birthday as 2017, and I was like, I told her that I'm not that old, or I'm not that young, and then she was like, oh, I got your birthday confused with your year.
So make sure you guys do your own. Here, I'll do mine right here.
Ooh, what year were you born? 2019. Wait,
19.
Oh, 19.
Oh, you're 7 years older than my mom.
That's really
My mom was born in 1990.
Yeah, Madeline.
On my thing, my birthday was last year, so it says I'm 11 when I do this because I'm born in 2012.
Yeah. So make sure did you use 2012 when you subtracted? Okay, it kind of depends what part of the year, right? And we are fresh into 2023. So it almost would make better sense to do 2022 because I'm not 26 yet.
25?
Mm-hmm.
Young. You're young. That's what my.
You guys are my favorite.
You're young. I thought you were like very young.
I am.
You're younger than my mom. 40. You're younger than my mom because you were born 7 years after me.
All right, guys. 5. I am younger than Miss Martin. 4, 3. Okay, let's pull it back together. I know. It's amazing, isn't it? All right. You want to pass 4th grade. You know I'm only 25, so.
Oh, you're.
All right, Jada recorded. Pull it together, please. Jada recorded the birth year of each of her maternal grandparents for a family history project. So here we have family members, and then over here we've got the year that they were born. Okay? As of this year, what is the age of each family member? Show your reasoning. Guys, it says to use the standard algorithm at least once. Is anybody in here using that expanded form thing?
No.
Okay, use the standard algorithm each time. That is how you are going to show your reasoning. So, for example, if I'm going to find out the age of her grandmother, then I would take this year, which is 2023, and I would subtract the year her grandma was born, 1952. Okay. What is 3 minus 2? 1. What is 2 minus 5? Oh, you guys are so on to me. Can we borrow from the 0?
No.
We have to come all the way over to the 2, right? Carry that 1. 10 becomes a 9. Okay, what is 12 minus 5? 12 minus 5 is not 8.
It's 7.
Thank you, Adley. It's 7. 12 minus 5 is 7. What's 9 minus 9?
0.
1 minus 1.
She's 71.
Does it make sense to say her grandmother is 71? Yes. That is a logical answer. But you're right, Erin, she could be 70 because we're just fresh into 2023.
Her birthday might have not been in January.
Very good. Okay, find the age of her grandfather, and then we're going to compare. So on your paper, 2023 minus 1948. When you have your answer, raise your hand. Are you done already?
No, I just wanted to say that her great-grandfather is probably really old.
Probably.
Harry.
Raise your hand when you have an answer for the grandfather. Keep your hand up so I know you're ready. That doesn't make sense to me. I think you're off. Something happened. Yeah, I think something happened. Oh, no. Yeah, no. Oh. Yeah, something happened, I think. Nope. I'm wrong. You're right. Never mind. Raise your hand. What did you get? How old is grandfather? Kira. 75. What'd you get? 175. Is that logical? No. Look back at your work. Maybe there's a mistake. Quinn, what'd you get? You got 75? What'd you get, Keston? 75?
75.
Okay, I'm going to speed check. This is how I would do this one. $75, right? Do you see what happened? Okay. 9 minus 9 is 0. 1 minus 1 would be 0. Somehow you got a 1 down there. Probably just need to look at how you lined up your numbers. Okay, figure out great-grandfather. Great-grandmother, like I said. Michael, raise your hand when you have an answer. So you're doing 2023 minus 1930. You just know it? Oh, what'd you get? Prove it with your algorithm.
Oh.
Do you have an answer?
Yeah.
Raise your hand when you're done. All right, I know what I got. Let's hear what you guys got. Maya, what'd you get?
93.
Raise your hand if you got 93. Pat yourself on the back. Okay, 3 minus 0 is 3. 2 can't take away 3, so we've got our borrowing going on, right? 12 minus 3 is 9. 9 minus 9 would have been 0. 1 minus 1 would be 0. Great-grandmother, 93. All right. Looks like we got one more. Great-grandfather, 1926. Oh, I'm going to make myself sound old, but that was the same year as my grandpa, one of my grandpas, was born. He's not alive anymore. That's how young I am, I mean. Do your subtraction. Raise your hand when you have an answer. Hadley, what'd you get? 97. So 4 years older than great-grandmother because he was born 4 years earlier. This one you probably could have figured out without subtracting because you could just think about the problem before, right? But you could check with your algorithm. We can't do 3 minus 6. We have to borrow. What's 13 minus 6? Everybody.
7.
Can we do 1 minus 2? No, we got to cruise over here and borrow, decompose. 11 minus 2? 9. So great-grandfather is 97. Okay. All right. Guys, which years did you find the easiest to subtract? Which were the easiest, Michael?
I'm pretty sure it was the great grandmother and the great grandfather.
Yeah, these years were easier. And why do you suppose that was? Why do you think, Madeline?
Because on the first number, you didn't have to decompose.
Right. So if you didn't have to decompose, if it was easy to subtract, it makes it easier, doesn't it? Those zeros, guys, can get really, really tricky. So we have to keep our eyes out for them. Which were more difficult? Which were more difficult to subtract? Kaylin, which one? Your face kind of said it all. Which one?
Grandmother and grandfather.
Yeah, these two, right? And why would you say that? Lots of borrowing, right? I mean, decomposing. That's our word. Okay. Lesson synthesis. Close your books. Put your pencil in the middle to save your spot if you want. Actually, I don't think we need them anymore. There's nothing more. Close your books. Look up here. Here are 3 expressions. How are they alike? First of all, tell me how they're alike. Aaron.
Because all the numbers, all the top numbers have 6 digits and all the bottom numbers have
4 digits.
4 digits.
Yeah. Yeah, I agree. They all have 6 digits on top, 4 digits on the bottom. Bella? Yes. How are they different? How are they different? Vivian?
The placing of the numbers are different.
Yeah. The 5s and the 0s, right? Quinn?
The 5s and the 0s. So
Yeah.
the second problem, or there's no 5. In the third problem,
Oh,
there's a
on
5
this
to
part,
hundreds.
right?
Yeah, and then in the first problem, it's in the tens.
Yeah, okay. All right, a friend is unsure how to solve the second expression. Explain to a partner how you would use the standard algorithm to find the value of the difference. Turn and talk.
So what you would do is you would need to
One, raise your hand to share. How would you do this? How would you do it? Raise your hand. Books should be closed. Keston, how would you explain to a friend how to subtract this? Never mind? Okay, you lost it. Okay, Jerica?
decompose the 5 and bring it over, bring the 1 over to the 0, and then make that, and then make that a 9, and then bring the 1 over to the 0, and then make that a 9, and then bring the 1 over to the other 0.
And then just subtract. Okay, no, you should not just tell them the answer. It says how to solve it. You're not doing them any favors just saying here's the answer. My goodness. Okay. All right. This is your cool down. I was like, where are we supposed to do this? Okay, guys, before we do that, today we learned how to subtract when we have zeros in the top number, a lot of zeros, right? And how to decompose. So, you're going to go back to your seat. I think, we have one more cool down after today. So go ahead and do your cool down and read a book when you're done, I guess.
Chocolate chip.